Now, let's begin with learning basic Java syntax. So, what are the primitive types and variables supported in Java? As usual, as all the languages support, Java also supports Boolean, character, byte, short, int, long, float, double, etc. as its data types. So these are the basic or primitive data types that are not object. So basically, when was developed, this was kept into mind that these are not the objects, but these are just the primitive types, and this was due to the performance issues. Whereas in the latest languages, we could see that such primitive types are also converted into objects. Although we have wrapper classes in Java that gives a form or a look for this primitive types as objects, so we can see those things in our later lectures. So what does this mean? So this means that you don't use the new operator to create a primitive variable. So all like for objects, we know how do we initialize those using a new operator. Whenever we create an instance of anything, we need to allocate a memory for that. And in Java, we make the use of new operator to allocate a new memory or create a new instance of that particular class, or you can say uh, instance of that. So in Java, for primitive data types, there is no need to use new operator. So below is the example of how we declare the primitive variable. Simply, if you want to create a float variable, just type float and your variable name. So just we need to keep in mind that the variable names cannot be the internal keywords of Java. Like for example, you cannot write float as your primitive data type and int, or you can say float as your variable name, because it is an inbuilt variable or inbuilt keyword into your Java. So we must take care that the variable names must not match the keywords that are inbuilt into Java. Otherwise, simply it will throw an error. Similarly, let us understand first why do we what is float basically. So float is used to store the decimal point data. So for example, if I want to store in terms of decimals for like the value of pi, take for example 3.14 or such values, so I write them in float. But one must keep in mind that float only supports 6 digits after your decimal point. This is because of its limitations of the memory that it holds. So, in order to store more than six variables or more than six digits after your dot, you can make use of double. So, double will help you to achieve that. Generally, it is quite advisable to use double over float while performing any decimal point operations. Next is we will have a look at int. So integer is nothing but a store integer values. You can say all the negative values and zero, and all the positive values. So integer is simply used to store non-decimal integers into your variable. So same way int and variable name. So here we can see there are two variables declared alongside, and also there is a variable initialization. So there are two things basically. Let me show you. So while declaring a variable, this is called variable declaration. Whereas when we assign a value to that variable, this is called variable initialization. So in the similar way as shown here, we can declare and initialize multiple variables in a single line to reduce your lines of source code maybe. So we can do this way. This is also completely fine. If you want to just declare and initialize it later, you can do this way. So this is just a small brief of how you can declare primitive types and those variables in Java. So let's come here. Yeah, so next data type is boolean. So boolean just stores your value in two formats, basically true or false. So it will return you a true value or false value, and these are nothing but the types of your primitive subtypes of your primitive data types. So char will store a character, like a single alphabet at a time. A byte will store a single byte, so one byte equal to 8 bits of data, that's it, maybe into a binary format. Short will store a small integer value. Int stores an integer value that is of 4 bytes. Long stores a integer value greater than 4 bytes up to 8 bytes. Float, as we saw, for decimal, and double for decimal with uh, more memory allocation. So these were some of the introduction to the primitive types and variables in Java. So as we saw how the initialization is done, let's get more brief into it, like what is initialization actually and how it is to be done in Java. So if no value is assigned prior to use, then the compiler will give an error. So basically in the latest Java, uh, the value, if we don't assign a value to our variable, if we just keep it like this, so it takes the default value as 0. So if you don't assign anything, your default value of that variable will be 0. So that is what is said over here. Java sets primitive variables to 0 or false in the case of a boolean variable. So in case of integer, it will set 0. In case of float, it will set 0, 0.0. And all object references are initially set to null whenever we create an object of any class, basically. So initially they are set to null unless there is a constructor defined. And an array of anything is an object. That is, when we declare an array, it is set to null on declaration, and elements to 0. What the elements inside the array are set to 0, false, or null depending upon the type of array on creation. So let's get ahead and see what things are to be done in Java. So declarations, these are some of the examples of how Java will throw an error in case of such kind of mishappenings takes place. So see here, the example is given. When we write int index, so it is understood that this variable is going to store integer value, and when you store this 1.2 into your integer, so there can be a compiler error. Similarly, when we write boolean ret okay, and if you store 1 into that boolean variable, it will throw a compiler error because it stores only true or false values. And similarly, if you store this thing 5 divided by 4 into double, it won't throw any error because double is capable to store your decimal values. For float, if you write like this 5.8 f, float ratio equal to 5.8 f, it won't throw error. So this f needs to be appended in Java while storing a float value, and this is not actually recommended while using double. So this f indicates that this is a float value to your compiler. Similarly, if you write something like this, double 5/4 equal to 5.0 divided by 4.0, it will return correct, so that won't be any issue with your compiler. So as given below, 1.2f is a float value accurate to 7 decimal places. Yeah, and 1.2 is a double value accurate to 15 decimal places. So as I said, float value only stores up to 6 or up to 7 decimal places after your decimal point, and when it is into double, it can store up to 15 decimal places. Now let's see how the assignments are done. Simple. The assignment operator is used for all the assignments in Java. So assignment operator is nothing but your equal to operator. So In this example, int a equal to 1, b equal to 2, and c equal to 5 is declared and initialized basically. And we are doing a equal to b equal to c. So in this case, the assignments are right associative always. So the value of c, that is 5, will be stored into b and it will get overridden with 2. And now b contains 5 and 5 will get assigned to a, whereas a initially contains 1, now it gets overridden with b. So when you just print those output, what you will see is the value of a, value of b, and value of c to be separate. But now in this case, the value of a will be 5 and the value of b will be again 5 and value of c will be again 5. So in this way, your all the values that were stored into your previous variable will get overridden with the latest value 5. Now let's get a look on the basic mathematical operators that are supported by Java. So as similar to the several languages, Java also supports the multiplication, division, mod, plus and minus operators. So these operators have their own significance. The star operator is used for multiplication. This slash operator is used for a division operation. This percentage sign or mod operator is used to return the remainder of your division. Plus is used for performing addition operation, and minus is used to perform the subtraction operation. So accordingly, like as every language supports, there is a precedence associated with each and every operator. So let's have a look at this example. Double my val equal to a plus b mod d minus c into d divided by b. So the precedence, or you can say the priorities to the execution of these lines, is associated as below. So it is similar to the following implementation, as you can see, that is a plus into the bracket b mod d minus c into d divided by b. So as normal mathematics, everything that is inside the bracket will be executed first and then later according to the precedence of the operator. So as you can see here, the multiplication, division, and mod have higher precedence than plus or minus in Java, and in that precedence, this line of code will be executed. So let's proceed ahead. So the statements and blocks inside Java, as we have seen so far, the statements in Java can be terminated using the semicolon. It has to be terminated using a semicolon. It is the convention of Java. And the block inside Java are encapsulated in the curly braces. So inside a curly braces, you can again introduce another block, maybe another curly braces. So that is not a problem, and Java completely supports that. So what is the flow of control? Java executes one statement after the other in the order they are written. So Java is the interpreter, as we have seen, and the statements are executed line by line, one after the another. And many Java statements are flow control statements. For example, we are going to see ahead, those are alternation, looping, and escape sequences. So alternation are nothing but if else, and switch. So these are also called as branching statements. We are going to see what those branching statements are. And looping, so loopings are used to execute a particular block or statement for more than one, you can say, or else until a particular condition is met. So those are for, while, do while, and we'll see those in a brief today. And the escapes are nothing but the break, continue, and the return statement. So how they work and how they behave, we will see into the succeeding slides. Let's proceed towards our first branching statement, that is the if statement. So similar to its meaning basically. So if statement evaluates an expression, and if that evaluation is true, then the specified action is taken. For example, here it is given. So if x is less than 10, x is equal to 10. So let's consider like we write x is equal to 10 and we just check if x is less than 10, then we will print something like this. So let's encapsulate it again in a class branch maybe, and let's encapsulate it in a main function. So here what we are doing is we have assigned the value of value 10 to the variable x, and we are checking if x is less than 10 then print high. So it will never happen, and simply the statement won't be printed onto your console. If the value of x is less than 10, like here what it is done is make x is equal to 10. It could have been written in this way as well, so, or alternatively in this way as well. So there are several different alternatives to write a similar statement in different ways in Java. So this was a simple if statement, and inside if statement, so as we have seen over here, less than, and accordingly we can use greater than and several other relational operators that are associated with the if statement. So what are those? Equal equal. So here I have written that be careful, this is not a single equal to, this is a double equal to. Single equal is the assignment operator that is used to assign a value from right to left, that is a right association, and whereas this double equal to is used to check your values with a condition. So if the both values are equal, the left and right values, then the particular operation results to true. So this is not equal to, this is greater than or equal to, less than or equal, greater than, and less than. So these are all the supported relational operators that can be used inside an if statement. If else statement. So what if the condition is false? So if block only executes the conditions those return true. So basically if the condition that is specified inside a if block is true, then it will print something. But what if we also want to handle the false occurrences, or you can say the false evaluation of an expression, so that is handled inside the else block. So similarly, we can write over here, like let's put this inside a bracket, inside a block, I mean. Okay, so else, you can print x is greater, and here you can print x is small. So what will happen over here is, now x is 10, x is not less than 10, so this evaluates to false, and it comes directly jumps to the else block, and it prints x is greater than 10. So this was if with else. And what with nested if else? So you can write multiple if statements inside another if, like you can say a previous or preceding if statement. So a short example is given over here. So consider there is a variable declared known as myval, and there is some value assigned to myval, and we are evaluating if myval is greater than 100. So if this condition is true, then it will get inside this if block. If it is false, it will jump directly to its uh, corresponding else block. So if this is false, it will print my value is in the range. If it is true, it will come inside this if block, and again this condition is checked. So that is uh, consider there is a variable declared remainder on above this lines, and if it is a boolean variable, so if it is true, if this expression evaluates to true, then this condition is executed, that is my val equal to sorry, this statement is executed, that is my val equal to my val mod 100. Otherwise, if this evaluates to false, it jumps to this corresponding else block and it performs this computation, and then it comes out of this block directly, it won't go into this else. So the concept is very simple for nested if else as well. Now else if, so suppose there are different alternatives of conditions which we want to use, and for that nested if else may make that application complex. So let me give you a small example by of see, we can find the greater among the two numbers, right? So let me explain you with an example basically inside this itself. So consider we have this three variables int a equal to 10, b equal to 20, and c equal to 30. So what we have to check is uh, if a is, we have to print the number that is greater among three, okay, the greatest among three. So that cannot be achieved using a simple if else statement, and using nested if else can make such applications complex. So let's use the else if ladder and find out the greatest number among the three. So how I can write, if a is greater than b, and so this is nothing but you can say logical operator. So we are going to learn about it in ahead. So and or and not, so these are three logical operators, and checks for the conditions where the both the conditions are true. So what we have to check, if a is greater than b and a is greater than c. So it is quite important to put here two and, because these two and are logical operators and single and is a bitwise operator. We'll see the difference between them into the succeeding slides basically. Okay, so if this evaluates to true, we have to print system dot out dot println a is greater. Hmm. Now what? Now we have to check for b. So using else if, we can evaluate else if b greater than a and b greater than c, then print b is greater. Again I wanna check for c, so one must make sure that you put the space between else if c is greater than a and c is greater than b, then print c is greater. And otherwise we have one condition, so there should be one else succeeding all this else if condition. We can say all are equal, right? So if none of this is greater, the condition is that all are equal. So if you followed me, you may have easily understood how we can use the else if ladder. So similarly, same way, and just if none of the conditions are evaluated to true, it will execute this else block. That is, if it has all the tests have failed, the else block will execute. Now let's go with some of the checks before proceeding ahead. See, if we write like this, if I equal to j, and inside that if j equal to k, system dot out dot println. So this is a wrong practice. So if you have multiple lines inside a single if block, so it is always recommended to put that block inside a curly bracket. If you have only a single line to evaluate, then there may not be a need to put a curly brace. But if there are multiple lines to be evaluated inside a if block, so it is always recommended to put those into the curly braces. So the correct way is given over here. You can write like this: if I equal to j, open a curly brace; if j equal to k, uh, evaluate and compute your things, else come out and print this. So this should be the correct approach to be followed, and not this one.